All right. Let's dive into some really cool stuff in image recognition. We're looking at this Google AI research you've been into,
Yeah.
and it's all about transformers
Yeah.
for image recognition.
Right.
And, usually we think of transformers for understanding language, right?
Exactly. Yeah.
But this is shaking things up.
Yeah, yeah, for sure.
So tell us a little bit about.
What's wild is this isn't just theoretical.
I
They
get that.
actually built a model, and they call it Vision Transformer, ViT.
Okay.
And it's going head-to-head with, like, the heavy hitters,
Yeah.
the convolutional neural networks,
Yeah.
the CNNs.
Okay, now hold on a second, because CNNs, that's
Yeah.
that's the gold standard. They've
Yeah.
been around forever. What makes
That's what makes this so groundbreaking. Because for the longest time, we've thought CNNs, with their intricate understanding of image structure,
Yeah.
were kind of unbeatable.
Right.
And VT is saying, hold my beer.
Okay.
In this paper, an image is worth 16 by 16 words, shows just how powerful it can be.
Wow. Okay. I'm intrigued, but how does a system even designed for words begin to see an image? It feels like we're comparing apples and oranges.
That is a great analogy.
Yeah.
It's a great analogy because
Okay.
it highlights how different these two approaches are.
Okay.
Like imagine a CNN.
Yeah.
It's meticulously going over a painting.
Uh-huh.
Every brushstroke,
Yeah.
every little gradient of color.
Yeah.
ViT, it's like someone walking through a museum.
Right.
They're not looking at
Oh, yeah.
every single detail.
Right.
They're trying to pick up the important elements, the important figures,
Mhm.
to kind of get the gist of it.
So instead of getting bogged down in the minutia, it's going for the big picture.
Exactly. Yeah. So
Okay.
what it does is it breaks an image down into these little squares,
Oh.
these patches,
Huh.
and it treats each patch as if it's a word in a sentence.
Okay.
And then a standard transformer, the same kind that's used to, understand us talking right now,
Yeah.
processes these visual words
Okay.
to figure out what's going on.
Okay. I think I'm following, but let's break it down for me.
Yeah.
So we're taking something that's visual.
Right.
We're chopping it up.
Yeah.
And we're treating it like language.
Yeah.
How on earth does that even work? What is a visual word? I'm still a little fuzzy on this whole visual word thing. Like,
Yeah.
are we saying that this splash of blue over here, that's the sky, and that blob of orange, that's a sunset?
Yeah.
How does it learn those connections?
That's the beauty. Those visual words aren't pre-programmed.
Okay.
It learns them
Okay.
by looking at tons and tons of data.
All right.
Remember those data sets?
Like that JFT 300M
Exactly.
with the millions of images.
Millions. Okay.
Yeah.
But how does just seeing more images actually teach it to understand what it's looking at?
So it's all about patterns,
Okay.
right? Think about it.
Yeah.
If you'd never seen a dog before,
Mm-hmm.
and I showed you thousands of pictures of different dogs,
Eventually you start to pick up, okay, 4 legs, tail, floppy ears.
right? The common features.
Even if they look a little different
Yeah.
from dog to dog.
Okay.
It's the same thing with these image patches.
So ViT's doing that, but with the image patches instead.
Exactly.
Okay.
And what's really cool is
Yeah.
it doesn't just see a jumbled mess of patches.
Okay.
It actually figures out where each of those patches belongs in the image.
Hold on.
Yeah.
How does it do that? Are we telling it where each patch goes?
No, that's the magic of
Okay.
these positional embeddings.
Okay.
It learns to associate each patch with specific location in the image.
Wow.
So it understands that this patch over here, this is, part of a fluffy tail, and it's connected to this patch over here, which is the rest of the tail.
So it's not just identifying objects.
Yeah.
It's understanding
Yeah.
their shape, their position, how they relate to the other things in the image.
Yes.
That's kind of how we do it, right?
That's right. Precise.
So that's how we perceive the world.
And it gets even more interesting
Okay.
because just like you're not paying attention to every single detail in this room right now,
Right.
ViT learns to focus on the most important parts of an image.
Okay.
It's called the attention mechanism.
Okay.
It's a huge part of what makes Transformers so cool.
Okay, so now that's really impressive.
Yeah.
But I have to ask, if
Yeah.
it's this revolutionary, why haven't we been doing it all along? What's the catch?
So there's no one catch, but it does come with its own trade-offs. Remember how we talked about, like, needing tons of data for this to really shine?
Right. Millions of images. Millions of images.
Yeah,
That's a lot of cat
a
pictures.
lot of cats.
But seriously, like, that seems like a big hurdle.
Huh.
Not everyone has Google-sized data sets lying around.
Yeah, that's very true.
So how much of a problem is that?
It's a consideration, for sure.
Okay.
And you're right, for a while, CNNs, they were the top dogs, especially with these smaller data sets.
Okay.
They've just had, like, decades of research, to get them where they are.
Okay, so like CNNs, they're the marathon runner who's been training for years.
Take
And
it, Zach.
and ViT is like they just showed up, but
Yeah.
they've got this potential to be a total game changer.
Exactly.
Yeah.
And the thing is that the gap isn't insurmountable. Like, even with those smaller data sets, the research found that the more you train ViT,
Yeah.
the more it closes the gap with CNNs.
Okay.
So it's like it just needs a little more time in the gym.
Yeah.
So it suggests that as these data sets grow, which they inevitably will,
Right.
VAT might just be like the go-to approach for a lot of these things.
Okay, so for our listener who's been knee-deep in this research,
Yeah.
what's the key takeaway here?
So it's not just about the grit.
Okay.
Right. It's about challenging the very foundation is how we think about AI.
Okay, I like where you're going with it.
Yeah.
Go on.
For years, we've assumed that to teach a computer to see,
Uh-huh.
we have to like program in all this knowledge
Yeah.
about how images work.
Mm.
Shapes, edges, textures, all of it.
Yeah.
But VIC is saying, maybe not.
Okay, you're saying we can just like
Yeah.
feed it enough data and it'll figure it out on its own.
That's the exciting part.
Yeah.
And it goes beyond just images.
Okay.
What if this approach, right, this training massive models on massive data,
Yeah.
what if we could apply that to other fields, other senses?
Like using sound instead of images.
Exactly.
Or analyzing complex data sets, but they don't even have a visual component.
Exactly. We're talking about a potential paradigm shift in AI.
Okay.
All from this simple but radical idea
Wow.
of treating images as language.
So what you're saying is this research, it's like that first crack in the dam.
Mhm.
It's opening the floodgates to all these new possibilities.
Yeah.
And it's really challenging these long-held assumptions about what AI can achieve.
Exactly. And that's what I find so cool about all this.
Yeah.
There's always something new to find, something new to explore.
Always another deep dive.
Exactly.
Well, on that note, I think we'll wrap up our deep dive into vision transformers.
Yeah,
We journeyed from pixels to patches.
that's right.
We explored these visual words.
Indeed.
And I think we peeked into the future of AI.
We did.
And who knows what we'll find there.
Exactly.
And listener, if this sparked your curiosity, don't stop here.
Keep digging.
Yeah, delve deeper into this research, ask your own questions, and hey, maybe you'll be the one to discover the next big thing in AI.
Maybe you will.
After all, the future of AI isn't just something we observe, it's something we create.
Well said.
Thanks for joining us for this deep dive, and we'll catch you in the next one.